Section 5.3, number 6, they've given you a function here. F of x is 4x to the 7th minus 3 cosine of x, and they asked you to find the general antiderivative of that. So if the function given to us was called little f of x, then its antiderivative is going to be capital F of x. So that means we are essentially going to do an indefinite integral here on both sides. Indefinite integral, or antiderivative of little f of x, we're going to call capital F of x. And now we're just going to antidifferentiate term by term. We're going to reverse the power rule here. That x to the 7th now becomes an x to the 8th because we increase the power by 1. And then we divide the old coefficient by the new exponent. So 4 divided by 8 is going to give us a 1/2 out in front of all that. Okay, then we're going to go to antidifferentiate a trigonometric term here, and we're reversing the process of differentiation from the first semester. And in the first semester, we talked about how the derivative of sine was cosine. So an antiderivative of cosine is going to be sine. So this should give us a minus, the 3 just tags along here, minus 3 sine of x. We'll check that in just a second, but because they asked for a general antiderivative here, we need to make sure that we put the plus c at the end of all that. Now we can check our answer to any indefinite integral or antiderivative problem by just taking the derivative of each term in our answer and making sure that that gets us the original integrand there. So let's try it. If we were differentiating 1/2 x to the 8th, we'd bring the 8th out in front, multiply it by the 1/2 and get 4, and then drop the power to get x to the 7th. So that term seems to work out pretty well. And the derivative of minus 3 sine of an angle would be minus 3 cosine of the same angle. And we put that plus c there at the end because there could be any constant added at the end of that function, the derivative of which would disappear. It'd be a 0 right there. So we put that plus c there just to indicate that we don't know if there's a constant or what it would be. So that's our general antiderivative there for the function given to us in number 6.